Welcome to Dreamscape Grove, a game where your focus level will determine a forest growing. So, as long as you remain focused, there will be new trees spawning, growing, taking up a square, and then expanding from there. But if you lose focus, they will shrink and disappear. Okay, to take a step back, let's discuss what brain-computer interfaces are. So, basically the idea is that you can read a person's mind and figure out what they're thinking, feeling, how focused they are, how calm they are, or something about them. Also, you can change things, but that's not something we'll talk about today. That's brain stimulation and for later. But right now, let's focus on where we can read. Now, the entire theme is all about neurofeedback. Neurofeedback is this phenomenon that if you can measure someone's brain activities and based on that make some sense out of it and present that as audio or visual form, like in our instance, because of high focus forest grows and because of low focus forest shrinks, person uses this as feedback to develop an intuition for how to control it. So basically, by playing this game for a long time, a person will develop the ability to control how focused they are in everyday life, which can help with ADHD and problems and basically everything focus related. Now, how is that even possible? I mean, we're talking about commanding focus. This can be sort of like meditation or enlightenment and such. How? Magic, perhaps? No, it's not magic, it's science. Really, let's see how it is. There's a couple ways to do this. One way is to use a magnetoencephalogram, another way is an EEG, there's near infrared. There's a lot of ways to do this, but most of these ways are either too invasive, which means we have to open up your skull and put some spikes inside it, which is, let's just say, not very comfortable, or it costs a couple $1 million and you have to go to a grand hospital to do it. So to be able to do it at home, pretty much always EEG is chosen because it's very affordable. Some are sold for even a few $100s, some for $1,000, but it's still way cheaper than $1 million megs. So yeah. How does it work though? EEG stands for electroencephalogram. It reads electrical activity on your scalp. Now what does that mean? As you can see here, there are some specific areas picked out, and on those areas electrodes are placed on your head which measure voltage that goes on in your brain. So the different areas have different names, like you can see on the picture. It's not very important right now, but basically left side of your head gets odd numbers, right side gets even numbers, central side gets Z numbers, and so on. But that's not important right now. What is important is how does this even work? And for that, let's take a step back into how our brain works. So our brain is made of neurons. Neurons are these amazing cells that build the computation, personality, and really everything that we are. How? They have a cell body called a soma, and they send out data through this axon, and they receive data from other neurons through this dendrites. So data is the output. So axon is the output, and dendrites are the inputs. Now, when two neurons talk to each other, it happens through an axon of one neuron talking to the dendrite of another neuron, and this connection is called a synapse. Now what's interesting is that the way neurons talk is that they spike. What spike means is that, as you can see in this picture, a jolt of electricity is being sent, and this electricity actually creates the change of voltage that we detect. And this change of voltage is how EEGs can know that some things are happening, and then we use some machine learning, some signal processing and other things to translate this, let's say, neuralese language into actual focus levels, calmness levels, and so on. For this, we have Neurosity Crown today, which is a consumer-grade device for well, it's right now for $1,500, so it's not that cheap, but if you keep in mind that the alternatives are like $1 million or require your head to open, it's still rather affordable. So basically this device promises to measure and help with your focus, calmness, raw brainwave data if you're into machine learning, or movement commands so you can have triggers to like take a screenshot when you think of biting a lemon or something like that. How? Well, we can measure our focus levels because we know some important thing called brainwaves. Basically, brainwaves means that Depending on how many of our neurons are active at the same time and how often they talk to each other, our brain develops these activities in different frequencies. So low frequencies are called delta waves, and they're when you are in a deep sleep or a coma. Theta waves are for light sleep or daydreaming. Alpha waves are for just relaxing or being distracted. Beta waves are when you're normally focused, and gamma waves are for when you're hyper-focused, like in an intense chess match. And we can determine that we are focused right now by pretty much comparing how many theta waves we emit and how many beta waves we emit. And if this theta to beta ratio is low, that means our focus level is high. Now let's get back to the topic.
Okay, so now let's take a look at how Neurosity does this. So you can see on their console neurosity.co that they have some settings for my device ID, what channels, which is basically what parts of the brain they take measurements from, and some stats we don't really care about. Right now this is offline because I'm letting it rest so that battery doesn't die, but basically what matters here is that they have this focus metric which they stream directly. And we can pick it up in our code and listen to it so that every moment we know what level of focus we have and we can adapt to it. So for that, I'm opening up VS Code. I have this very small Node.js code, and here's what it is. So this is Neurosity SDK, which we can find on their GitHub, right here. In Neurosity's account, they have this SDK.js. And it goes into some examples, but right now this is a very simple use case. We just have their ID, email, password, and what port I want to expose this on my machine. And here's what we do. We log into the device, we make sure that we connected right, and then the focus metric that they give me, I recast it on port 9001 on my machine so that I can listen to it in Unity. I could just directly subscribe in Unity so that things would be much easier and we would not have to recast and do this rebroadcasting thing, but they did not have a ready-made Unity SDK, and I was too lazy to write it, so for now this is the approach, but in the future for sure I will get rid of Node.js side and I will directly do it from Unity. I'll write the SDK myself, so stay tuned for that, I guess. Now, what this does is once we run this, let's see. Let's quickly get to the path of this guy. We can see here, we can just say node focus-osc-bridge.js. Although in this case it would not work because we first need to enable this device and make sure it connects to the same internet. For which, by the way, I will be using the Neurosity's mobile app. So this is the app that we'll be using. We'll make sure to connect our device through Bluetooth. There, connected. So now that it's connected, we can choose what Wi-Fi network to use. I'm going to use my personal hotspot from my phone. And now we can see here that once we run this, we should be able to detect it. Let's see. We log in and we probably started streaming. Now to test this, it's time to put it into use. So let's just run the code and see what would happen. Right now it should be giving random noise since I'm not wearing it, but by the way, I would be wearing it like this. So these two ones on the back would be measuring my occipital lobe, and these ones my parietal lobe and my frontal lobe. I will have a separate explanation for all of those. But yeah, basic idea is that these ones are for focus, these ones are for visuals, these ones are for motion comments that we could give. So here we can see that this is just mock, which is just a sine wave. You can see we can set a minimum threshold that we want, so that the tree starts growing. And if we were to go back to Neurosity, now here we see this is the focus recordings coming straight from the Crown, and it's giving some random numbers. It should get better if I wear it. Somehow I got it to even worse. Oh yeah, okay. So this actually needs to be trained to tune to the person's focus level. I haven't done that in a while right now, so it's kind of messy. But yeah, once this is trained, this is giving us current focus metric, and based on that, we are going to grow a forest. That's the essence of it. Okay, now let's dive into the actual code that goes into this. And by the way, we can see what this looks like. Like this square will fill, then these sides will fill, then these sides, and so on with random trees. Now to see the actual code base on the Unity side, let's get into that right now. So the code base on Unity side looks like this. So we have the scripts folder, and it has adapters, core, gameplay, UI, and utilities. Let's start with the core. So we have, for instance, a focus device. Let's see. Focus device for now is just what type of input we want for our focus data. We have mock data, which is basically just a sine wave, and Neurosity Crown. In the future, I will add Muse and OpenBCA and other famous EEGs, but for now it's just these guys. Let's see what else we have here. We have a focus interface, which is just focus frame, which is what we get every second or every frame duration, which is just when we receive this, what level of focus we got, and how confident we are that this is the right measurement. So this is just from 0 to 1, and this is also from 0 to 1. And this is just an interface for focus source, which is implemented by Neurosity and also by the mock. Now we have a FocusManager, which is perhaps a little fancy, but the basic idea is that it allows us to switch between different focus devices, right now between just mock data or Neurosity Crown. And here we have node bridge process, which spins up this Node.js code so that we can run it from Unity side, so that we don't have to actually manually run it before playing. Now we have adapters as well, which is specific devices for getting input from. For example, we have this mock focus source guy that gives us the initialization and then just sine waves value at that time. You can see here mass_f.sine multiplied by some scale in 0.5, so that on average this is on 0.5 instead of going from -1 to 1. This goes from 0.1 to 0.9 pretty much. And here we have the actual Neurosity OSC source. This is the most dense part of the code, you could say. So what happens here is that we open a UDP connection to the port which we exposed over here, as you remember. So here we stream data to port 9001. So here in our code, we listen to port 9001, and we see that every time there's some new data streamed to this port, we receive it, we convert it into a number, and then we convert it into our focus metric. So from this, we receive our focus value, and based on that, we output a new frame, which is just timestamp of current time, the focus value, and how confident we are. In this case, since Neurosity Crown doesn't give us confidence value, we just hard-code it at 0.95, 95% basically. And then we use that to grow the tree. In the gameplay here, we can see we just move around with a camera. This is a standard RTS camera controller, nothing special about it. We have some tree growing logic so that we can grow trees when we're focused enough, or shrink and delete trees if we are not focused. So basic idea is that we figure out if we need to grow or shrink, and then we do so accordingly. And this is just a visual for growing a tree, which just scales the tree up. And we have a logic for spawning trees in squares. We have different types of trees as scriptable objects. And we have stages of a tree's lifetime so that they look slightly different, small versus big. Now, with all that in mind, we have some meaningless UI code as well. Not meaningless, but not the most important part right now. And all that together gives us this logic that we can essentially grow a forest when we're focused enough, or shrink it when we're not focused. And of course, we have this UI in the game, which lets us see if we are connected to our current source, the minimum focus we need so that trees grow, minimum confidence level we need so that we don't ignore the message. And here we see our current focus level and the required focus threshold, so that if the focus is above that, trees grow, and below that, trees shrink. So this is the main idea behind our code, and now let's see it in a proper demo. Well, first, to allow the forest to grow up so that we can see what's going on, I'm going to set the minimum required focus to 0 and let the mock run so that some trees can spawn. And meanwhile, I can just take my time strolling around, seeing that I can look around. Yeah, the ground could use some work, could have a lot prettier texture for sure. This is just simplest setup. So right here we can see it says connected because we are always connected to the mock device. If I switch to Crown, you can see it says not connected right now because we need to set it up properly. But yeah, basic idea is that if we move a required focus down, then the forest will shrink, or otherwise it will go up, and we can connect to the Crown for the more accurate data. So this is the goal of the game. And if we set the required level of confidence up to 1, which neither the mock nor the real Neurosity Crown gives us, then the forest data would not change at all because it would not be a reliable input to judge it from. So yeah, this is the idea of it. And this is something that can be used for neurofeedback to train your focus. Now I will improve this UI, this is just a proof of concept, and you can stay tuned as we improve the accuracy on this and make it more useful for actually treating issues with focus and ADHD and such.
So to summarize, we saw that we can measure our focus using the Neurosity Crown device, hypothetically with another device as well in the future, but for now it's the Crown. We saw how our brainwaves mean, how EEGs generally work, how this game is set up, how this code is structured. By the way, the full GitHub repo will be in the description and in the comment as well. And for the future, we will improve the signal processing. We will dive into more computational science details so that we can actually determine the focus level ourselves from the raw readings. We'll also obviously improve the textures and the UI so that we can turn this into something that can actually be used clinically, like to cure ADHD or maybe even addictions once it's on a high level, because neurofeedback potentially gives us the ability to gain absolute self-control by training for it. And this is an immense opportunity because in this era, there is a war of attention by social media algorithms. The recommendation algorithms all give us reels and shorts and things to keep us hooked, and we're going to fight it this way. Also, by the way, brain-computer interfaces will very soon open us up into a realm of superhumans. I'm talking like the kind of intelligence difference between humans and apes is the kind of difference we might see between people using brain-computer interfaces and people not using them. This is all coming step by step. So first by accelerating the rate of learning, giving us more absolute self-control, giving us focus and such, and then by enhancing from there, perhaps by attaching to our neurons directly a digital layer of a brain, so to speak. More about this in our next videos. Cheers.